Hey everybody, welcome to another episode of Behind the Cape. I'm data superhero Keith Belanger. I'm joined today by fellow data superhero James Weakley. Welcome, James. Thanks for joining me today.
Thanks, Keith. Happy to be here. Should
Yeah,
be
so
fun.
yeah, I'm excited about this topic. We're going to be talking about native apps today, and it's something I'm actually really curious about. So, yeah, take us away. Let's hear all about it.
Sure. Well, I've actually been building and selling native apps around Snowflake for about 3 years now, which probably sounds confusing because the Snowflake Native App framework's only just been launched, 6 months ago or so. But to provide some context, as a relatively early Snowflake customer, I saw value in being able to live query Snowflake from Salesforce, and I couldn't
Okay,
really find an easy way to do that. So I actually built a native application for Salesforce a few years ago, and eventually founded a company around it, which is still that product's still in market, still going strong. So it was actually Salesforce that proved the native app model to me, as a founder,
oh,
um,
nice.
and um, but my co-founder and I, through this process of selling this Salesforce app, we really saw that the center of gravity for data was definitely Snowflake,
Right,
and that a lot more use cases would be forming around that platform, as opposed to the kind of more niche use case we were solving for Salesforce plus
right.
Snowflake customers, which has a limited sort of scope to it. So we decided we wanted to build a native Snowflake app, for data integration long before the framework ever existed. Um, this was around the time that a lot of new products were popping up in that ecosystem. The sort of reverse ETL
Right.
term was being coined. But we were really keen to do something Snowflake native. But through kind of waiting for that process, we were part of some pretty early conversations with the native app team, and we got to sort of hear about what was in the works fairly early. And so we actually started building our Snowflake app alongside the development of the native app framework, sort
Okay.
of in parallel. So that was how we were able to launch very quickly. As they announced the marketplace, we were
Right.
straight on there. And so that's really helped us become the top app in terms of transaction volume, and get a bit of a head start.
So you guys were
Um,
blazing the trail there with Snowflake.
yeah, on the bleeding edge, which is always fun and exciting and a bit scary.
Yeah.
Um, but yeah, I guess I was keen to maybe share a few things about the journey of building a native app, the trade-offs that you make by doing it. I guess starting with when is a good
Yeah.
fit for a native app. Does that sound good?
No, that sounds great. I'm just as you're talking about it, I'm thinking and I'm kind of going back a few years and we were really in a position where we always had that like let's bring the data to our app, right? Not
Yeah,
bring the app to the data. So you guys started blazing that trail and now it's kind of a different way of thinking. So, yeah.
yeah, yeah. It has played out, thankfully, the way we thought it would, and the native app framework is really solid already. So um, I guess jumping in, in terms of the trade-offs, and I guess if you're thinking in your head like, are native apps for me? Because you've got native apps and then you've got connected apps, which are
Right.
apps that um, closely integrate with Snowflake but are still outside of the native app framework. Um,
Right.
and a lot of any vendor that supports multiple different data warehouse products or data platforms typically is a connected app as opposed to a native app. Whereas a native app is deploying Snowflake objects in a managed package that reside in the customer's Snowflake account. So you're creating tables and tasks and stored procs and things that are all running in that account,
Right.
which is quite different to connecting in from the outside.
Right.
You get its limited little sandbox where you can request more privileges as you go, but ultimately you're running in the customer's environment and they sort of control what you can and can't do.
Can do.
Um, and I guess when we're thinking about, we've done a lot of modeling about the the commercial side of doing this. Naturally, if you build a native app, like it has to be said that you're limiting your market size in terms of you're only going to address the Snowflake portion of the market. And you're also sacrificing some choice around which technology you can use.
Right.
You can't just pick any framework that you want. You have to typically be happy with Python predominantly, and also, I guess, Java and JavaScript, Scala, whatever else you can do on the Snowflake platform. So you kind of have to be really focused more on the problem you're solving and not be too fussy about which exact languages and frameworks you prefer. Um, but on the flip side, for that smaller subset of the market you address, you have this much better architectural fit with the customer's environment. You have so many building blocks provided for you that you can get to market quickly with perhaps a more full featured product,
Right.
which I'll get to a bit more later on. Um, the other question I guess people might think, is it easier to build a native app than to roll your own stack? And I think sometimes the marketing around native apps, people might confuse with some of the messaging around no code platforms or low code platforms where you can be a business user or maybe an analyst building an app. Um, and certainly in my career, I think I've visited most parts of the stack, written assembly code for embedded systems. I've racked servers and connected up, networks and everything along
The
the
good old
way. And
days.
yeah, yeah, that's right. Out in the data center, and then building on top of several different SaaS platforms. And in my experience, if you want to design and build a complete product as a native app, you still have to have a very good grasp of what you're doing architecturally.
Right.
You have to understand, in this case, Snowflake very well, how they all what's happening under the hood. Otherwise, you can easily design yourself into a corner and cause yourself a lot of pain. So, I guess I would say don't make the decision to try and lighten the cognitive load of designing a product, because it won't do that. It just helps you not think about stuff that may not be your value add. So
Right.
if you're solving a problem that revolves heavily around data, needs to be nice and close to the data, Snowflake customers are a big part of the market, then you can gain quite a big advantage by being native on Snowflake. You can start with a smaller team. You don't have to build and manage, keep the lights on a bunch of infrastructure. Surprisingly, you'll be able to work with larger companies quicker, if,
Right.
which is people don't realize, because they don't have to trust you to handle their data as much as they would have to trust a vendor that's handling their data.
Right.
Um, and I found along the way, there's actually like a segment of the market who, kind of the enterprise end, who are comfortable with trusting a small number of big vendors, like say AWS, Snowflake, Salesforce, have all been approved for workloads, but are hesitant to be adding a bunch of smaller SaaS into the mix, which are
Right.
handling their data. So a lot of these data tools fall into this category where they're good at what they do, but they're not like a huge name, not as trusted.
Right.
Um, and so
And the
you don't even have. Sorry.
I was like, and then the more you introduce into the architecture, the more possible points of failure, right? And leaks you bring into that. And I can understand that, right? Is that, hey, if
Yeah.
we can have, you know, less of those opportunities of breach, the better, right?
Yeah. So we expected that we would begin to compete with some of Snowflake's other partners, which are connected apps that do data integration, but actually there is a portion of the market who were not ever going to buy those tools anyway because they were worried about the risk. So we're actually just competing against that company just doing it themselves on their own internal
Gotcha.
governed infrastructure. So that's a helpful thing to keep in mind. Um,
Nice.
and then the other, I guess, advantage is with all these being able to get straight to solving the problem by having this pre-built stack. you can offer more features than other competitors who are a lot of people are trying to like pick the common ground between all the different data platforms and come up with a product feature set that kind of works on all of them in a similar way. Whereas we just optimize for Snowflake, build everything tightly coupled to Snowflake, and then have a broader feature set. So our product does a lot more than what uh, a vendor who's kind of spread across a lot of different
Right.
data platforms can do. So in some sense, it makes up for that limited market size.
Yeah, so you're able to go more narrow but very deep in terms of all the capabilities that are within Snowflake.
Yeah, so we're just on Snowflake, but our product does. We're a data sync tool essentially. We do both directions, which isn't always the case. In
Right.
and out of Snowflake, you can build customers build their own connectors, and these are things that you can focus your time on when you're not thinking about infrastructure.
Great. On the stuff that you really want to be focusing on, right?
Yeah, exactly. Yeah.
Yeah.
Um, should we talk about the dev process? The
Yeah.
um,
Yeah. I think I'd give a little bit of highlights on how that process works. That'd be fantastic. Yeah.
yeah, cool. I've got some slides to kind of go with
Okay.
this,
Let's
um,
share that.
and I'm conscious that Omnata's we've been kind of racing the roadmap in terms of tooling because, as you can imagine, a small company building stuff on a large company's platform, you're sort of often racing ahead of what their um, tools can do. So some of what we've built has probably been superseded in terms of the packaging and deployment tools. Snow CLI has had a heavy focus from Snowflake, which we're looking to transition some of our tooling. But in this section, I'm just going to focus a bit higher level and talk about the overall process. So, in the classic 3-tier architecture, application paradigm, your native app is going to look something like this diagram. So you've got your data tier. Naturally, that's Snowflake tables, which you create in your setup script. Soon you'll be able to pick from things like hybrid tables if that makes sense for your app. Um, then you've got the application tier, which is typically like your kind of API layer in a typical app. In the case of Snowflake, it's mostly stored procs. And then presentation is kind of chosen for you, really. Snowflake have chosen Streamlit as the presentation layer for native apps. Now, some people might argue that Streamlit should just be for presentation and that you should do everything through stored procs if you were really going to separate your app really neatly. But I think that would be fighting against its strengths in a lot of cases. So, by its nature, Streamlit likes to work close to the data with data frames and running queries. So, I think the best thing to do is just maintain a little bit of logical separation in your Streamlit code, but don't try and force everything through a stored proc. Um, and then, as far as Streamlit goes, I'd make a couple of strong recommendations here because um, you see the example Streamlits kind of work well for like a dashboard where you've got a few charts and a few buttons. But if you're trying to build a complete product, you quickly outgrow that pattern. Um, and just to quickly, put some, um, I'll just wake up my native app. If you look at our app, um, it's a fairly new app and it's already presenting quite a lot in its UI. So, um, you, if you've got things like all these menu items displaying different things, and these are different syncs, and we're drilling down into stuff quite a bit. There's a lot going on as far as stuff on different tabs. And so all the possible things a person might do on this page becomes quite vast very quickly, um, and will only continue to do so. And especially when you're helping people navigate through and around a product in different ways, we've chosen to go into a particular sink here and have a look at some data. This is a lot of like this would be an incredibly complex Streamlit single page app. So what I suggest people do, and I demoed this in the last build summit, which is to start to use some abstractions in your Streamlit code base. So um, just as a little example, um, if you've got some thing that's like a widget that you want to use or reuse in different contexts, we've got these classes that essentially it's kind of like if you've ever used React in the front end world, it sort of has that philosophy of separating the state from the rendering. So in the initialization method of the Python class, you're kind of gathering all the data from different places, from tables or wherever you need. Whatever data is required to kind of render that thing is done there. And then later on, there's a render method which has all the Streamlit stuff in it. And then other widgets can sort of look at that state further on. And you can include these multiple times in different pages. So what you end up with is like the homepage of a Streamlit app just has a handful of widgets that wants to display, and then all the complexity of those things is elsewhere. So you end up with like an organized code base that is a bit more maintainable. Um, the other thing I recommend is using data access objects. So I think if you don't have to do this all the time. If you look at our history page, for example, we've got these charts that are showing activity. Um, with those, we're kind of just querying the tables directly and not worrying too much about that structure. Um, but for everything else, where you have these, like, for example, the history of a sink, that's coming from a structure, like a well defined table that we created. And we know the columns and the data types, and we sort of want to carry that typing into the code base rather than just do snowpark kind of data frames and just have the names of columns and try and make sure we get that right. So what we do is for every table in our native app, we have this data class which defines all the columns and their types, and it includes things like if it's nullable, it's optional, um, and uh, it's also got like lookup. If you've got foreign keys in your tables, it can do the lookups for you. So you get all this type hinting in your Python code base to sort of help you when you're coding to make sure you're calling the right column, like you're looking at the right column name, and that's all kind of enforced for you. And finally, we like to use object columns to store more structured stuff. Um, but the danger there is, like, keep in mind with a native app, you don't have access to the data. So you've got customers deploying it, but you never actually see you can't just go and look at the data that is in their account. So if you have a bug or something that writes some incorrect object data to like a object column, it's very hard to fix that. So we actually lean quite heavily on a library called Pydantic, which lets you validate structured objects. And anytime we're using a Snowflake object column, we're actually storing a Pydantic model. And anytime we read from that table or write back to the table, it's going through that Pydantic validation. And that sort of provides like a guarantee that we're not writing um, object data that we didn't expect to, and we have to try and tidy up later. Um, so that's how I recommend managing Streamlit. Um, and I guess the final part I was going to cover was like our deployment process. Um, if you like, get into that. Um, so when we're doing local development, we have a Snowflake account just for development. We're using VS Code locally to do all our coding. That includes like the backend, the setup script with the tables and everything else, and up to the Streamlit at the top. And from VS Code, we can deploy to our dev account just into an individual developer's app package, and we can deploy an instance of the app and go and check it out. While we're in local development, we deploy the app in debug mode, which means you can see the internals of the app, which a customer normally couldn't. What that means is we can fire up Streamlit locally and point it at that app instance, and we get that good sort of hot reload behavior of Streamlit. We don't have to recompile and deploy a new app package every time you change a line of Streamlit, which is really important. Um, Once that's all working, we push to a Git branch that starts with dev, which essentially defines it as a development branch. Um, and then the second part of the branch name is the version number of the native app. So you can have different versions of an app being developed and deployed at different times. So we use branching in Git to maintain that separation. And a GitHub action will check out this anytime you push a commit. It's going to run the unit tests and then deploy the um, application package to a test environment and create a temporary instance of that native app just so it can run all the tests, and then it's going to delete it at the end. And we run a lot of tests in parallel, so we have a process for doing that. Um, in terms of the tests, we use a Python framework called Behave, and I'll just show you like what the report looks like of a test run. So Behave has this kind of plain English way of describing what you're doing. You have this given, when, then sort of syntax, and so you describe the test in relatively plain English, and then you've got some Python code that interprets these steps and actually performs the action on the native app instance. So typically it's something like, given I have a table that has these particular rows in it, and then I run a stored proc, then I expect the stored proc to respond with this, and then I expect these other tables to look like this. That's the typical approach to testing that middle layer. Um, and then we actually also test the Streamlit UI as well. We use a library called Playwright to do that. And so that spins up like a headless Chrome on on the GitHub Action instance, and it actually opens Streamlit in Snowflake on our Snowflake test account, and actually clicks around. And the cool thing about Playwright is that even though it's headless, it actually records what it's doing. So you can actually watch the replay later. It uploads a movie file, and you can see it clicking around. And if one of the tests fails, you can easily see on the screen what the screen looked like, which can make it easier to figure out what went wrong. So, as an example, earlier in the week, we had a bug introduced to a stored proc that Streamlit relies on, and so we have this. This was a um, bug that affected a certain part of the product. And so you can see if you watch the replay, I'll just skip forward a bit. At a certain point, um, something happens, and you can actually see the Streamlit error, um, which means you don't have to go and try and visualize it. You can see there's a little SQL syntax error in the mix there. Makes it easy to hone in on what you've broken. Um, and then Uh, Once all the tests have passed, we merge to a branch that starts with main but has the same version name, and then that's where we actually we deploy the new package version to what kind of our production environment. It's like our partner account, um, and it's it's managing the application packages which are actually linked to our marketplace listing. And so this is kind of the source of the true packages that the customer installs. Um, and then from there, we're just managing what's called release directives, which are like defining which customer gets which version of the app. We have a lot of native apps because each of our connectors is its own app. So we actually have some scripts which kind of manage in bulk our release directives and lets us do things like we have an internal release just to our own accounts and some of our partners or early adopters. Also, we can, if we're working with a particular customer on a particular connector, they can get the first release of it, but not everything else. So we've got quite a lot of flexibility in the way we push out new packages as well.
So as if you have, customers that are using from the marketplace, when you do an upgrade or an update to a newer version, is it up to them to go to the marketplace and then bring it down, or does it just automatically go through to their the Snowflake account?
It's all controlled by the provider. So it's the provider's job to push out the change. Now, if your customers have different risk appetites of how, like, they've got to make a decision of, quickly getting new changes versus waiting for other customers to experience whatever pain might come with those new versions. You do that through release directives. So you might just agree with the customers. You can opt into this part of the phased release process, and they just trust that you've implemented it that way. There's not really like a customer can kind of force install an upgrade if when you update a release directive, there's usually like a delay while there's like a scheduled task. I think it runs hourly, that the customer can kind of shortcut with a SQL command. But generally speaking, it's controlled by the provider.
Yes. And if a customer has multiple accounts within the same region, then that app would have to be installed on each of the accounts.
Yes, that's right. Yeah.
Right. Oh, great. This was very informative. So I don't want you to cut you off. Do you have any more slides, or it was
No,
this is
that's it for the slides.
right? I'll bring back our pretty faces here. Um, so no, I greatly appreciate this. Was very informative. It's an area of in data that I don't really venture into that space, so it's very informative to really understand what's going on there, hear a lot about it. I'm sure others have, so this was great. Where, if others are interested in finding more information, James, where might they be able to go learn more about it? Maybe your product, so forth.
Yeah, so if they're interested in just native apps in general, I think the Snowflake developer, like the dev days, the build summits, the stuff that the Snowflake community team is doing for developers is your best bet. If you're interested in our product, Omnata, you can either go to omnata.com, or you can just go into the marketplace in your Snowflake account and search for us, and you'll see us, and you can just self-serve a trial of the app from there.
Great, and for everybody, we'll actually have all of these links and information in the comments for the video. But again, James, I want to thank you for joining me today, and this was very informative. And thanks for coming.
It was a pleasure. Thanks for having me, Keith.
Thanks. We'll see everybody next time. Bye.